Conformity Index is a useful tool to quantitatively assess the quality of radiotherapy treatment plans. Let's take a look at the various ways the Conformity Index constraint can be used in ClearCheck. Conformity Index represents the relationship between isodose distributions and target volume. A conformity index of unity implies high planning target volume coverage and minimal unnecessary irradiation of surrounding tissues. In ClearCheck, the body structure on the DVH is used to calculate the volume of the specified dose. Therefore, it is important to make sure the calculation volume encompasses the entire body structure. The DVH lookup feature in ClearCheck allows the constraint to be more accurately evaluated. This is also why users may see differences in manually calculated conformity index values when using isodose volumes generated from contours. Using the volume from a structure created from an isodose line will result in discrepancies. ClearCheck offers several ways to set up the conformity index constraint. You can use either absolute or relative values. There is flexibility for you to choose any isodose level you'd like. You can set upper and/or lower limits. Ideal values can be identified in addition to limit values. There is the ability to evaluate a range of volumes in a lookup table, and you can also calculate conformity index for multiple structures individually in the same plan. Let's look at a few examples. First, I'll start with a lung SBRT plan. I'll launch ClearCheck and go to the Template Manager. I'll create a single upper limit conformity index constraint for the PTV using the 100% isodose line. Then I'll set the upper limit to 1.5. If the conformity index is less than or equal to 1.5, it will pass, as you can see here. To create a lower limit constraint, simply add a greater than symbol to the end of the constraint. This will change the limit value to a lower limit instead of an upper limit, which means that if the conformity index is greater than or equal to this value, it will pass. For demonstration purposes, I'll leave the limit value the same. As you can see, the less than or equal to sign has changed to a greater than or equal to sign, and the result now shows as failing. Some protocol constraints include a per protocol or no deviation category, as well as a variation acceptable or minor deviation category. For example, in RTOG 0813, the conformity index for the prescription isodose volume to the PTV ideally should be less than 1.2. However, a minor deviation or conditional pass is also accepted for conformity index values greater than 1.2 but less than 1.5. Here's how this would be shown in ClearCheck. In this case, the result is passing since the conformity index is less than the ideal limit of 1.2. To account for a range of volumes, a lookup table can be created in ClearCheck. Rows in the lookup table can be added using the plus sign icon and deleted using this icon. Using RTOG 0813 again as an example, the ratio of the 50% prescription isodose volume to the PTV volume for a range of PTV volumes would look like this in ClearCheck. For this lung plan, the volume of the PTV is 11.62 cc's, which is not an exact match in the table. So in this case, ClearCheck will interpolate to determine the ideal and limit values for that PTV volume. We can see here that the result for this constraint is a conditional pass. Now let's look at a breast protocol example. This example uses the RTOG 1005 protocol. The conformity index that I will use is defined as the ratio of the 95% prescription isodose volume to the volume of the breast PTV eval. Ideally, the conformity index should be no less than 0.95 and no more than 2.0. with an acceptable variation of no less than 0.85 and no more than 2.5. Visually, this is what this constraint would look like. For this type of constraint, in ClearCheck there would need to be two constraints created, one constraint for the upper limits and one constraint for the lower limits. In ClearCheck it would look like this. The lower limit constraint has a greater than sign after the constraint, and because it is a lower limit, the ideal value will be greater than the limit. The preferred conformity index value for this scenario would be one that passes both constraints, which means that it is greater than the lower ideal value and also less than the upper ideal value. Finally, let's take a look at this multi-met SRS brain plan. In Template Manager, for this case, when I create my PTV conformity index constraints, I will select the margin expansion checkbox. Then I'll enter an expansion value that is greater than the isodose cloud that's being evaluated in that constraint for that structure. So for this example, I need to make sure the expansion value is greater than the 100% isodose cloud. So I'll enter 1 cm for each PTV constraint. ClearCheck will create an ROI expansion based on the specified value and calculate the conformity index using that volume. Thank you for your time. And if you have any questions, please don't hesitate to contact support@radformation.com.